All right, in this video, we're going to talk about finding inverse functions. And let's say I had f of x is equal to 3x plus 10. And I want to find the inverse function. The best way to do this to start is you want to change your f of x into y. And the only reason you do this is it makes it easier for you to move things around. So this is only to make it easier for you. Now I'm going to invert. And by doing that, I'm going to swap x for y in my equation. So now I get x is equal to 3y plus 10. This is my inverted function. But now I need to solve for y. Great. So I'm going to subtract 10 from both sides. So I'm going to move the 3y over here and this over here. I'm going to get 3y is equal to x minus 10, right? So I subtracted 10 from both sides. That goes away. X minus 10 I'm going to put over here. 3y I'm going to hold over here. I'm going to divide everything by 3. I'm going to get y is equal to 1/3 x minus 10 thirds. Here, I can go back and I can change my notation now, where I'm going to make y is equal to f minus 1 of x to indicate that this is my inverse function. And that's it. And that's how you do all of these for finding your inverses, is that you make it easier for yourself by switching y for f of x, and we're just rewriting it here. And then you invert by exchanging the variables of x and y. And then we want to solve for y to actually get our inverted function, and then change the notation back into the inverse function notation. If we look at the graphs of these, this one we've got 3x plus 10, so we've got 10 here, we've got a slope of 3, it's going to look something like this. Here we've got an y-intercept of negative 10 thirds and a slope of 1/3, so it's going to look something like that. And what should happen is there should be a perfect line of reflection right down the middle. And in fact, at the line of reflection, that value will be a solution in both the original function and the inverted function.